Okay, so let's go do this question now. What will the updated weights be? Here's what we've got. I need some way to refer to them. I call these weights 1 and 2 and bias 1, and we'll call this weight 3 and bias 2. That's how most of you who came up with your own labels use that convention, so I'm trying to be consistent with you. I should have put little labels on this graph so that everybody would do it the same way. But when I say bias 2 equals, I mean this bias term right here on the output unit. And when I say weight 3 equals, I mean that number that used to be a 3 is going to get updated. And I'll also update bias 1 and weight 1 and weight 2, which are connected to x1 and x2, because that's kind of convenient. Okay. How do you update these things? Well, they're all going to take this same form. See what I'm doing here? I'm basically saying, for all of them, take what used to be there and add the learning rate times something, times whatever the gradient is. Some of you computed the gradient term separately and then added it to the weights. That's cool, good way to do it. I'm just going to do it on one line because I am. Most of you did it this way. So what goes inside of these parentheses is what's on both ends of the weight that we're about to update. And for the bias terms, what's on the input end is just the number 1 always. So it doesn't really affect anything. In other words, we're going to use this number for the output ones. And there will be something times that here. And we're going to use this number for the input ones. And there will be something times that here. You with me? This is the blame on the output end of those things. So now we just need what value is fed into them. And we get that from back when we did original activation, the forward propagation. So what number was fed in as x1? It was a 0.2, right? So I'm going to stick a 0.2 there, and it was a 0.7 here. And what number was coming into weight 3? That's this one right here. It was a 0.04. You see that? Because 0.04 is what came out of this unit, and it's what went into that 3. So where did I put it? There. 0.04. Okay. If you wrote these equations like that and put the symbols here instead of the numbers, then you showed me exactly what you were doing, and then that was super easy to follow. Here I just spat out the numbers. As long as you got the numbers right, then it was super easy to follow. If your numbers were wrong, I had to do a whole bunch of poking with a calculator to try to figure out how you got those numbers. Do you want me to do the math for you? Nah, you can all plug this into a calculator, right? Okay, so whatever those numbers are, you write them down on this picture. Some of you didn't write them on the picture, you just gave me the symbols. Okay, I worked with it. I'm not going to penalize you for that. But that's how we did that problem. I know that was a pain. I know it forced you to remember stuff, but I really kind of told you it was coming, didn't I? I mean, there were only 3 or 4 questions that we prepped for, and that was one of them. I don't think there was a lot else I could think of to put on the test, so it was kind of inevitable, I think. Moving on. This last problem, we might finish with a little extra time, in which case I can teach something on convolution. Okay. Consider the following table of data. Admittedly, this data is not, I don't know why I disclaim it. Okay. So here's some data. Did you like my funny joke? Somebody's favorite animal was the chigger. Ha ha ha. Nobody's favorite animal is the chigger. We all hate chiggers. That's why it's funny. Okay, nobody thought that was funny. Elephants are kind of cool, aren't they? They're big anyway. There you go. Cranium's, is cranium circumference related to ACT score? We all like to hope it's not, don't we? Truthfully, there is a correlation. Isn't that disappointing? It just makes you feel rotten about society inside to know that there's a correlation there. It's not a strong correlation, though. It's mostly a weak correlation. So there's plenty of room for people with small heads to get high ACT scores. It just happens that there's a bit of a correlation there. Nevertheless, this problem, all of the features are distractors. You just ignore them. And almost everybody figured that out. Good on you. At training time, the baseline algorithm ignores the training features and computes the mean of the labels. At prediction time, it ignores the features and predicts the mean of the label values. Okay, so we're doing cross-validation. Let's do it. We're going to do 3 folds, so I'm just going to write fold 1, fold 2, fold 3, like that. And now I can, okay. So if this is our data, and the baseline algorithm computes the mean of the training data, then what's it going to do? Let's do fold 1. So if we're doing fold 1, almost everybody decided that in fold 1 you're going to withhold this pattern. If you did it in some other order, you still got the same answer, so that's okay. But let's do it the same way everybody did it. So fold 1, this is your test pattern, and the other 2 are the training patterns. By the way, I picked 3-fold cross-validation with a data set that had 3 rows on purpose, because that way there was absolutely no way you could chop it up differently than I did, right? And that's important on a test. You will never work with 3 rows of data in the real world. That's ridiculous. But having disclaimed that, let's do cross-validation anyway. So the baseline algorithm, as described, computes the average of your training data. What's your training data on the first fold? So these 2 rows, right? It's not all 3 rows, just these 2. So the average of 24 and 30 is 27. So in fold 1, it will always predict 27. And while we're at it, let's just compute the prediction for the other folds. When we're withholding chigger, it will always predict 25. You see why? Because the average of 24 and 26 is 25. So it will predict 25. And when we're withholding this pattern, it will predict 28, because 28 is the average of 26 and 30. Okay. Is it? Thank you. Second one's 25. This time it predicts 28. Okay. So you can't usually just figure out what it's going to predict, but because it's the baseline algorithm, it always predicts a constant value, and that makes this assignment a lot easier. Note that the baseline algorithm does not use y equals mx plus b. That's a linear model. That's not the same thing. I know we did cross-validation in assignment 1 with linear models. You don't have to use a linear model to do cross-validation. You can do cross-validation with any model you like. Okay, so what will the error be? How do we define error? Target minus prediction? Sound good? Okay, so if we do that, then what will the target in fold 1 be? We're only going to test on this one pattern, right? If this is our only test pattern, our target is 26. Do you agree? Okay, and we're predicting a 27, so our error is 1. Is that right? Yeah. Actually, I think error is usually prediction minus target, not target minus prediction.
We're doing some square.
Yeah, we're going to square it in the end anyway, so it doesn't even matter. Okay? In this case, error is equal to, let's see, we're trying to get a 30. We predicted 25. 25 minus 30 is negative 5. Finally, we're trying to get a 24. We predicted a 28. 24 minus 28 is, wait, is 28? 24 minus 28 is negative 4. Okay? So, some of you got that far and stopped, but when answering a test question, always read the question. What will be the resulting sum squared error? Your answer was to compute that. So let's compute the actual, finally, sum squared error equals 1 times 1 plus 5 times 5 plus 4 times 4. It's actually negative 5 times negative 5 or negative 4 times negative 4 or something like that, which is equal to the answer to life, the universe, and everything is 42. Yay! And that was the end of my test. Oh, that's weird. Okay. Now you know the whys of everything on the test. How about a quick post-mortem? Did that test measure what you learned in this class at all? A little bit? Good. That's what I was shooting for. Were you surprised or by anything? Or were there any good questions I should have asked that I didn't? Because I couldn't think of a lot. I could have done the please derive backprop in symbolic form one. I didn't do that, and I kind of made you study for it. So, I made you study for that. That one's still open for the next midterm, because I'd really like you to be able to derive backprop in symbolic form. So don't feel like you were ripped off if you didn't get to answer that question. Anything else?
OLS.
What was that?
OLS.
OLS. Oh yeah, I didn't really test OLS. Truth is, OLS was really just an exercise in can you do linear algebra for me. It's a good thing to know, but I don't know, it's not really my baby like neural networks are. I love neural networks. OLS only works with linear models. What's the point? Who likes linear models anyway, right? That's my opinion. But OLS is cool because it was kind of the first regression solution ever. So it was the birth of machine learning as a field, really. Okay. Oh, there's pre-processing stuff like nomcat and normalization and that. I kind of figured pre-processing stuff is a practical matter, and therefore you should learn it in practice rather than in theory. That's my opinion, but you know, I don't know. That would have been nice to know in the midterm review, not now, right? Sorry. But hopefully your studying was good. So I've got your midterms. I'll pass them back at the end of class. I've learned enough to know that if I hand them back now, you won't hear a thing I say the rest of the class period, because you'll be looking at your answers and scouring for things you can argue for points. I get it, that's fair. If you have a technicality, if you think I misgraded your question or you think you deserve more points, please do come see me. I really actually do want my test to be fair and to give you all the points you deserve. If it's a matter of subjective judgment, I'm going to ask that you kind of go with my subjective judgment, because I had to grade everybody and I want it to be uniform, right? So on subjective matters, I'll push back a little if you argue with me, but then again, there are always cases where I didn't understand what you were doing. So if you think I read your question and I just didn't get what you were saying, and you actually were saying something reasonable, even if it's not perfectly right, that's a perfectly valid reason to come talk to me. But if it's just, I need an A because my dad will kill me, then sorry, that's kind of what tests are about, is trying to treat everybody fairly. So is that reasonable? If you have a really grumpy thing, take a cool down day before you come talk to me. If you have a technicality, please come talk to me immediately. I'm happy to battle it out with you on whether a question is right or wrong. And it's okay to prove me wrong. If you do, I'm not going to be angry and hold it against you when I do your grades. I love being proven wrong. Did a paradigms test this morning, and I actually, one of my distractors, it turns out, was technically wrong, and a student proved me wrong, and I was happy to learn something new. I even learn on tests sometimes.